All right, hello, good morning, good afternoon, or good evening, depending on what time it is wherever you are. You could be on vacation in Florida, lucky, or you could be sitting in detention, I guess. Maybe not so lucky. But that's one of the beautiful things about this flipped classroom. You can watch the videos anywhere you want. All right, so anyway, today I'm going to show you guys about arithmetic sequences. Um, there's really two kinds of sequences that we'll be looking at in Algebra 2. The first one is arithmetic, and the second is geometric. And arithmetic means you're adding or subtracting over and over again to get the next number in the sequence. All right, so if I went 2, 4, 6, 8, 10, that would be an arithmetic sequence because I'm adding 2 over and over again. All right, so when we get to geometric coming up and later on in the chapter, I'll explain what that is. But that's geometric is where you multiply or divide over and over again. All right, so the arithmetic sequence, it has a formula, which is nice. And it's written right here. Sometimes I've seen a 1 on this right here, right that. Sometimes you see that. I didn't see it in your book, but either way, it's A or A of 1, not to be confused with A of n, which is over here on the left side of the equal sign. That's A of n. That's how you say that with the subscript, the little n at the bottom. So let me explain to you just quickly what the variables are. A would be the first number in the sequence. D would be the common difference. And I'll show you what each one of these things are in an example very shortly. N is which number in the sequence it is. For example, the 10th number in the sequence. And then last but not least, A of n is the number in the sequence. All right, so you can write those things down. Hit pause if I went too fast. And I'm just going to jump in with number 1 right off the bat. And the first thing that I'm going to ask you to do is to be able to identify whether a sequence is arithmetic or not. Identify whether the sequence is arithmetic. Okay, and we'll have A and B, parts A and B. First one goes 3, 6, 9, 12, 15, dot, dot, dot. The dot, dot, dot means it keeps going forever. Even though we're not going to write down every single term, it does keep going, sequence or a series. And, in this case, this one's really straightforward. If I take the two numbers and subtract them, that's generally what you're trying to do if you get stuck. Sometimes it might give you decimals or fractions, which would be trickier. But if I subtract them, I get 3. If I subtract these, I get 3. That has to be the same for all of them. If 3 of them are 3 and the last one is 4, that's not arithmetic. That would be something else. However, in this one, they are all the same. And therefore, yeah, it's arithmetic. If you have questions, write them down, bring them to class. B. Oh, and one more thing before I move on. Suppose it doesn't say it, but if they were to ask for what is the common difference, the common difference is what you get when you subtract the two numbers. If you took the second number and subtracted the first number, because sometimes it could be a negative number. In this case, it's not. Common difference is 3, so D would be 3. Okay. Now I'm going to move back to the second one, part B. 1, 5, 9, 13, 17. And once again, if it has a common difference, then it's arithmetic. So if I went 5 minus 1, that better be the same as 9 minus 5, which better be the same as 13 minus 9, which better be the same as 17 minus 13, which in this case, they're all 4. Which means D, the common difference, is 4, and yes, it's arithmetic. Okay. Number 2. What is the 100th term of the arithmetic sequence that begins six, 11, ... Okay, so they told us it's an arithmetic sequence, therefore you can assume that you're going to add or subtract over and over again. Obviously, in this case, you're going to be adding 5. All right, and they want to know the 100th term. So, if you're masochistic, you like to inflict pain upon yourself, is what that means. Then you can sit there and extend that pattern, keep adding 5 over and over again, do it 100 times, and you get your answer. Not the way I'm going about it. Instead, I'm going to use the formula because there is one, and it's nice to use it. A of n equals a plus n minus 1 times d. And I'm going to start plugging in values. I'm just going to write down what each one of these things are. A of n, we don't know what that is. That's whichever number. I mean, it could be 6, it could be 11. In this case, I'm actually going to have it be 100 eventually, or I'm going to find out what number it would be when I plug in 100 for n, actually, is what I should say. So a is going to be the first number in the sequence, which in this case is 6. Okay, it's right there. D, I know D. I can find the common difference. That's 5, because 11 minus 6 is 5, which is D. And I guess that's all I have here. So, but when I plug these values in, now like I said, I want to know what is A of n when I plug in the 6 for A. D we said is 5. Now I want to know what the 100th term is, so I'm going to plug in 100 for n, okay, because that's the number that I'm looking for. And then that will tell me what my answer is, which number in the sequence. So if you punch that into your calculator, 100 minus 1 times 5 is 495, which means the 100th number in the sequence is 501. You could say A of n. You could also say A of 100. Sometimes you might see a notation like that. That means that the 100th number in the sequence is 501. That's another way you might see it. If you have questions on that, bring them to class. All right, number 3. What are the second and third terms in the arithmetic sequence? (100) space 82, and the sequence keeps going. Okay. So, I'm looking back at this formula for this one. Once again, A of n. If I have this formula, I can find out anything. If you have all the variables in the formula. It's really like the explicit formula. Now, I know that the first number in the sequence is 100. And I know the fourth number in the sequence is 82. So if I could find D, that would make it really easy, because then I could just, if the common difference was 3, that means you'd add 3 over and over again. I could take 100 and add 3, and get the next number. Now, obviously that's not the case. Since the numbers are actually getting smaller and smaller, I can tell you right now that D is going to be a negative number, whatever that may be. Okay, so what I'm going to do is I'm going to plug in, I know that the fourth number is 82, so if I plug that in here, that's too big, so if I plug in my 82 there, and I know that first number is 100, and I need to find out what D is. That's really what the problem here is asking for. Now this is probably not the only way to do this, but it's the way I'm going to go about it. And I also know that, the fourth number, when I plugged it in, I got 82. So that's what N is 4 for this case. So now if I do out the math, that's 4 minus 1 is 3D plus 100 equals 82. This is an easy equation now to solve. Subtract 100, and I get negative 18 equals 3D. Therefore, D is negative 6. Okay, which means if I go back to my sequence, 100 minus 6 is 94. And 94 minus 6 is 88. I should do it another round just to check it to see if I subtract 6 here, do I get 82? Yeah, okay. All right, so you're good. So those are actually the two answers, 94 and 88. And that's it. Why don't you guys try this one? Do a you try, number 4. What is the 46th term of the arithmetic sequence that begins 3, 5, 7, ... I would do it with a formula, but you guys can hit pause. If you want to do it the long way, go ahead, hit pause. I'll see you in about an hour. If you do it with the formula, I'll see you in about 30 seconds. All right, welcome back. So, this one, I'm going to take the formula A of n equals, let's see, the first number in the sequence is 3. And I'd like to know what the 46th number is. Common difference is 2. And if I plug those numbers in, 45 times 2 is 90. And 90 plus 3 is going to be my answer, 93. Okay, so 93 is the 46th number in the sequence. Let's do another you try, number 5. What are the second and third terms in this arithmetic sequence? $80 blank blank 125. Okay, so you can do that one. Hit pause, come back in a minute, I'll show you the answer. Okay, welcome back. So, if I take the formula, the A of n equals, if I plug in the first number is 80, plus the fourth number is 125. I'm trying to find D. So since that fourth number is 125, I'll plug it in there. And now I'll solve it out. 3D plus 80 equals 125. And if you solve that out correctly, you get D equals 15, which is great. Not the final answer, but something I needed to get there, which means I'm going to be, these numbers are getting bigger and bigger, so if I add 15, I'll get my first number of 95. If I add 15 more to 95, I get 110. And if I add 15 more, I get your fourth number, 125. Okay. So there's a definition for an arithmetic mean. And I think you guys, this is the mean that you're used to. When we get to geometric mean, it'll be a little different. Mean of x and y means you add them together and divide by 2. Which means if I have a question where, what is the missing term? In the arithmetic sequence, 15 blank 59. It's easier when there's only one number missing as opposed to the ones we just did. Actually, this one's an easier kind of problem because what you're looking for is the arithmetic mean. If I add those two numbers together, the 15 and the 59, since there's only one space between them, and divide by 2, I'll find out what that middle number is, which in this case is the arithmetic mean, which is 37. Which means 37 is the missing number. Number 7. So one kind of real life kind of problem for this is the number of seats in a sports arena form an arithmetic sequence. Row 1 has 14 seats. Row 2 has 16 seats. Row 3, oh, no, never mind, not row 3. How many seats are in row 13? Lucky row 13. Okay, so now, you can take this and just start making a sequence thing here, and you want to know that's row 1 and row 2. That's your sequence. You want to know what's in row 13. So I'm going to use that formula once again. A of n, first number in the sequence is 14. N minus 1. Now, since I want to know the 13th row, I'm going to plug in 13 for n. I'll write the formula here for you. A plus n minus 1 times d. So it's 13 minus 1. D would be 2, because it's getting bigger, right? We add 2 to get from 14 to 16. And now if I simplify this out, you get 14 plus 12 times 2 is 24. So A of n would be 38. So there's 38 seats in row 13. Last problem, why don't you try? Number 8. Same problem, same setup. Except row 1 has 20. Row 2 has 23 seats. How many seats are in row 16? Okay, so hit pause, do that one out. That's a U try for the last one. And then I'll show you how to do it. Okay, welcome back. All right, so let's see. A of n equals 20 plus 16 minus 1 times d is 3. So a of n will equal 20 plus 15 times 3, which will give me 65. 65 seats. Okay, that's it. Have a nice afternoon, or evening, or morning, whatever time it is with you, and I'll see you all soon.